Adults made up 5/12 of the crowd of people at a concert. After a bus carrying 50 more people arrived, adults made up 11 out of 25 of the people at the concert. Find the minimum number of adults who could have been at the concert after the bus arrived. Okay, so I think what I'm going to do is just set this up as the number of people, the number of adults and non-adults at the concert before and after, and just set up a system of equations which is consistent with the information that we're given. And then that system of equations, of course, the variables should all be positive integers. Hopefully we can identify what the smallest number of one of these quantities is. Anyway, so let's say A1 is adults before the bus, and A2 is adults after. And let's say N1 is the non-adults before, and N2 non-adults after. So we know that A1 divided by A1 plus N1 is equal to 5/12. That's, the proportion of adults before the bus arrives. And we know A2 over A2 plus N2 is 11/25. This is the proportion of adults afterwards. And then we need, I guess we have that the number of people before plus 50 is equal to A2 plus N2. Right? 50 new people. Could be some mixture of adults and non-adults. Okay, let's take the first couple of equations and rearrange them and see if there's anything we can do. 12A1 is equal to 5A1 plus 5N1. So 7A1 is equal to 5N1. And the second equation, 25A2 is equal to 11A2 plus 11N2. So I've got 14A2 is equal to 11N2. Okay, so my three equations then are that one, and I've got 7A1 is 5N1, and 14A2 is 11N2. We're looking for the smallest possible value of A2 such that these three equations are satisfied. Well, I'm just trying to think if there might be some kind of something in the question that should give us some, like a shortcut towards the answer, something we can use? I mean, the original proportion, 5 over 12, is, gosh, is a little bit less than 50%, right? And 11 of 25 is even smaller than that. So in the number of people on the bus, maybe I write it even as the proportion. If I write things in terms of the proportion of adults on the bus, it has to be, in order to bring the proportion down, the proportion of adults on the bus has to be even lower than this. And those proportions, the weight that I put on these two proportions is going to be well, I'll put a weight of 50 on that one and a weight of the total number of people here on that one. So if I say something like the number of adults on the bus is A2 minus A1. That's the proportion of adults on the bus. And if I multiply that by 50 and add 5 over 12 times the number of people there before, which is A1 plus N1, and divide by 50 plus A1 plus N1, this has to equal 11 over 25. I mean, it's just another way of writing some of the original information we're given. We don't have any new equations here, but this might be a more convenient way of figuring things out. I'm not completely sure about that. It does look pretty messy. Well, if I rewrite this as so the proportion of adults after times the total number of people, that's going to be the number of adults after. That's the number of adults before, and that's the number of adults on the bus. So does it make sense now to multiply through by some kind of common denominator? Do I have to look at prime factorizations of things here? Like 14 is 2 times 7, 11 is prime. So A2 is going to have to be at least 11 right? Let's see if A2 equals 11, if I get solutions to this. Let me write the equations again. I have 7a1 plus 7a1 is equal to 5n1. 14a2 is equal to 11n2. So we're going to try a2 is equal to 11. Then I get 14 times 11 is 140 plus 14. So that's 154 is equal to 11 times n2. So of course n2 is 14. So then I have a1 plus n1 plus 50 is equal to, oh, this can't possibly work. A2 and n2 are 11 and 14. That's just 25. Okay, I'm kind of seeing now. A2 obviously has to be a multiple of 11. What if we try 22? 22 won't work because then that's 22. This will be what would that be? Would it be 7? No, it would be well, let's just try it. Let's try it. A2 is equal to 22. So I have 14 times 22 is equal to 11 times n2. So 14 times 2 is equal to n2. Okay, so a2 plus n2 is 50. Yeah, that's exactly what I thought would happen. But we can't have 50 because that's the total number of people who were on the bus. That would mean the total number of people to start with were 0. So maybe hopefully this works out with a2 is equal to 33. Then I have 14 times 33 is equal to 11 times n2. So n2 is equal to 14 times 3, which is 42. Is that right? 30, yep. So a2 plus n2 is then 33 plus 42, which is 75. So then the number of people before a1 plus n1 plus 50 is equal to 75. a1 plus n1 is equal to 25. Well, this doesn't really work either because I need a1 over 25 to be equal to 5 over 12. And that's not possible. Okay. I don't really want to just keep guessing and checking here, but I feel like we'll get there eventually this way. Well, let's do it like this. Let's do it in the general case. A2 is a constant times 11, and I have 14 times A2 is equal to 11 times N2. So 14K is equal to N2. So A2 plus N2 is equal to 25k. So I have A1 plus N1 is equal to 25k minus 50, which is equal to 25 times k minus 2. And I also have, what was the original equation for A1 and N1? 7A1 is 5N1. So this says A1 has to equal to 5 times some constant m. So 35, well, let's configure this out more easily. 7 times 5m is equal to 5n1. So n1 is equal to 7 times m. So a1 plus n1 is equal to 12m. Okay. So I need 12m to be equal to 25 times k minus 2. These are relatively prime, so I need k minus 2 to be a multiple of 12. Well, maybe a better way of doing this. I know I see the smallest value of m is 25, and the smallest value of k is 14. I should have known from the context of the contest that this comes from that by counting, by doing case-by-case basis like this and just counting up by multiples 11, it would have taken quite a while to get there. But doing this did help in that, you know, I was able to just set things up in a general form. Let's continue though, make sure we get this. So A2 is k times 11. Times 14, which is, wait, did I not try this before? When did I multiply 11 by 14 earlier? So I said A2 is 11, but it's not 11. It's 11 times 14, according to, if everything I've done, if the reasoning I have here is correct. So A2 is 140 plus 11. No. 140 plus 14, which is 154. And let's see if we can figure out the other numbers as well. So N2, we know that 11 N2 is 14 A2. So N2 is 11 times 14. Interesting, which is also 154. Okay. Wait. So this means the number of people on the bus is 50%. I thought... Oh, did I get this? Did I get these the order of these ratios mixed up? Did I do this wrong? I mean, we didn't end up using that, so, but that's a very silly mistake. Okay, well, I have now N2 and A2. They're both equal to 154. So then A1 plus N1 is equal to 154 minus 50, which is 104. So how many adults would there be? A1 divided by 104 has to equal 5 over 12. Have I made a mistake here? Because I don't think 104 is divisible by 12. No, it's not. Okay, so what have I done wrong? Oh my goodness. I must have... Oh my goodness. I canceled off the wrong thing here. N2 is 14 times 14, not 14 times 11. $196. So we check 154 over 196. These have a common factor of 14. This is 11 divided by 11 plus 14. So that's 11 over 25, which is exactly what we want. And then down here, I also did this wrong. This is supposed to be A2 plus N2. Okay, so A1 plus N1 is equal to 154 plus 196 minus 50, which is something. I mean, this is the answer, 154. I did that wrong. I canceled off a 14 with an 11 for some reason, so that I had a 154 here, which I should have known is a mistake because I knew that these two things were not equal. And then that is supposed to be A2 plus N2, not A2. Anyway, I feel like, I do feel like figuring out all the numbers here. So this is 104 plus 196, that's 300, right? So I have A1 over A1 plus N1 is 300, which should be fine. A1 plus N1, oh wait, no, it doesn't equal 300. A1 over 300 is equal to 5 over 12. So A1 is equal to 5 times 300 over 12. That's A1 is equal to 5 times, this is 5 times 60 over 12. So A1 is 125 and N1 is 175, as I found below. Okay, yeah, so the answer, 154. Got there a lot earlier than I expected, but then when checking my work, I ended up making mistakes. So that's a little bit annoying. But I guess there were a couple parts in this that were kind of important. The first is setting up a simple statements which correspond to the information given, which is easy to do if you simply declare a couple variables like that. And then rearranging the equations. I should have probably skipped to this earlier, but when I see these equations, there's things you can certainly say. Because 14 and 11 are relatively prime and 7 and 5 are relatively prime, there's things you can say about these variables. A2 obviously has to be a multiple of 11. A1 obviously has to be a multiple of 5. So I probably shouldn't have gone through guessing and checking these individual values of A2 and just gone straight to a general setup like this. And then everything I did down here is correct until I wanted to check what the other values were going to be. Anyway, I got there in the end. 154 is the answer I get. If I have a mistake, I'll let you know. Thanks for watching.